Hello, welcome everybody in this next Titan webinar. The Titan project is about enabling transparency in food supply chains via the implementation of innovative and mainly digital technologies, but not only, to boost health, sustainability and safety of product processes and diets. We made a very exciting program for you today. We have two eminent speakers. First, we will have Venla Kytta from Finland, presenting about the integration of nutritional and environmental impact assessments to, let's say, to design a diet that is healthy and fits within the planetary boundaries. And we have a presentation by Professor Chris Elliott from Northern Ireland, and he will present about data fusion in combination with data analysis, also very exciting results. We will have the first presentations, then we have a short Q&A session, and then we split up into subgroup where we have hopefully very nice discussions. The Titan project is quite complex. Within the Titan project, we have identified 4 key expertise areas. One is to enable consumers to make informed food choices, and this holds aspects on food safety and authenticity and food fraud, but also aspects on informing and educating the consumer. The second key expertise areas we have identified is facilitating supply chain sustainability. And here we see an environmental and social aspect. For instance, we look at ESG reporting, but we also have an eye for economic support for SMEs. Then the third key expertise areas we have identified is the implementation of new innovative technologies, where we look into faster and or more accurate detection methods. We mainly look at DNA-based detection methods within Titan, but also we look at disruptive digital technologies like AI, machine learning, and so on. And then the fourth key expertise area is taking the food system approach, where we look at what is needed to move towards a sustainable food system, but also what is needed to be successful in innovation. The webinar of today fits within the third key expertise area, the implementation of new innovative technologies, and we are really looking forward to hear what the presenters have to bring to the table. These webinars are organized for the Titan Network of Expertise, which is an opportunity for you when you become part of this community of experts. You can actively contribute to shape the future of transparency innovation in the agri-food sector. When you become a member, then you join a vibrant community, you stay informed and contribute. You will be informed about results within Titan earlier. You can expand your network, and you can, as I said, co-shape the future of our food system. Then for Titan, every 3 months, we publish a newsletter with items that we think are, let's say, relevant to inform others about. One is that from the previous newsletter, that we had a publication where we were on 3 pages describing the Titan project and its ambitions, had this paper published. Another news item is that Professor Maja-Liisa Erkkilä received the Apple of Good Knowledge Award from journalists in Finland because of her activities to promote and explain the new Nordic nutritional recommendations in Finland. And also there was an activity where Carla Teixeira, a PhD within the Titan project, presented her work, where PhD students came together to discuss their research on food safety and authenticity. When we share the newsletter, we also share a PDF with relevant publications and relevant reports for the topics that we are responsible for. You can see the suitability of analytical methods for assessing food authenticity, so that fits perfectly with the presentation of Chris, and also the voluntary versus mandatory use of food labels. This is a paper from Australia, but this fits, you could say, with the work of Venla, because it could be something her work is enabling. And then we have a weekly newsletter Titan Weekly that we share every Tuesday on LinkedIn, where we have for all the key expertise areas nice news items. We also propose conferences to go to and where Titan will be present. We propose webinars that are relevant, and we bring some nice opportunities like funding or surveys or trainings that can be followed. The next webinar is planned for the 10th of June, where we will be talking about taking the food system approach. And again, we have two excellent speakers, François Capel, an innovation advisor at Innovo Switzerland. He will present what is innovation and what is important to consider when you want to be active in innovation when you have a researcher background. And then the second presenter will be Adam Adamek. Oh, I'm sorry, I didn't change this. He is the impact expert at AIT Food, and he will present about a recent impact report. And the results from AIT Food were quite good, so we are looking forward to an excellent presentation here. Okay, that's it from my side. I stop sharing, and I'm really happy to give the floor to Venla Kytta to present her work.
Thank you, and good afternoon, everyone from Finland. Let me just share my presentation. I think you should see it now, right? Yeah.
Yes.
Yeah, so my name is Venla Kytta and I work as postdoc at the Natural Resources Institute Finland, which is abbreviated LUKE. And here I work in the Sustainable Food Systems and Society group. Today I'm going to present you our recently published new paper. It's published in Sustainable Production and Consumption. And the QR code should take you directly to the publication, but I can also share the link in the chat after this presentation if you want to read more about that. Okay, so shortly about the background of the work. You probably all are familiar with the concept of the planetary boundaries, which basically defines the environmental limits which within humanity can safely operate, and crossing these boundaries can cause different kind of irreversible environmental changes. And the first assessment of these boundaries was published in 2009, and after that there has been 2 updates. And as we can see from this picture, there has been more boundaries assessed, but also the progress of crossing these boundaries has been very fast. So currently about 6 out of 9 of these assessed boundaries has been crossed, which is very clear warning signal that we need some urgent action to reduce the environmental pressures and restore the Earth system stability. Agriculture is a major driver of exceeding the planetary boundaries. This figure is from a study by Campbell et al. From 2017. And we can see the contribution of agriculture exceeding the different planetary boundaries that is marked with the black dots in the figure. And then the colored parts shows the state of the planetary boundary, so that the red ones are the ones that were crossed in the 2015 assessment. So based on this, we can say that changes in the food system are really needed, and also changes that we make in our food system can have very notable impact on the environment. But well, typically the environmental impact information that we get looks something like this. For example, this is very typical kind of result that we get with life cycle assessment. Here we have the carbon footprints per kilogram of different food products. And typically how we use this kind of information is to compare different products to others and then see what kind of decisions we should make to decrease the climate impact. For example, here we can see that okay, if we choose lamb instead of beef, we can reduce our climate impact. But the question, what we are interested here is that, okay, yeah, it's less bad, but is this really enough? Is this reduction, if we make this change, is it enough? So basically, we want to know what is sustainable, meaning that the environmental impacts are within the planetary boundaries. So we want to define the quantity, how much is sustainable. In this case, we could think that, okay, is below maybe this line is sustainable, so switching beef to lamb is good enough, or is it somewhere else? Should we change beef, for example, to beans to be sustainable? Another reason why we want to study the product level is that the environmental impacts as well as the nutrient composition of food can have very huge variation. So this is a figure that's made from meta-analysis of hundreds or maybe even thousands of LCA studies. So here we have carbon footprints. On the x-axis, you can see that the carbon footprints are per 100 grams of protein, and then the colored area for each food shows the distribution of the carbon footprints collected from different studies. And what explains this huge variation is basically, well, it might be some methodological differences, but most of it comes from the different production systems. So some kind of agricultural systems are more sustainable than others. And for example, on top, there is the carbon footprint of beef, and there's the little white dot in the purple colored area that shows that on average, the carbon footprint is about 25 kilograms of CO2 equivalents per 100 grams of protein. But if we look at the lowest carbon footprint of beef, which is somewhere like around 5 CO2 equivalents, we see that in many cases it's less than other protein-rich foods, being lower than the average of chicken or fish, for example. And this same applies for other products as well. For example, the highest carbon footprints of nuts are higher than the average of many different products. So there's a lot of variation between individual supply chains that basically provide the same end product to consumers. Okay, well, the planetary boundaries are kind of obvious criteria for the environmental impacts, but the food should also provide us some nutrition, because if we look at only the environmental impacts, the result would say that we should just consume whichever food has the lowest environmental impacts, but we also need the nutritional aspect of food. So currently, unhealthy diets are the largest global burden of disease, contribution to undernutrition, overweight, obesity, and micronutrient deficiencies. That's why we took this kind of two starting points that, okay, in order of food product to be sustainable, it should provide enough nutrition and then also be environmentally sustainable. And maybe you know the work by Eat Lancet. It's summarized in this plate figure that they already published 2019, where they assessed how the food system can be fit into the planetary boundaries while we also ensure healthy diets for all. But here we really wanted to know how can we assess individual products to define if they are sustainable or not, because the diet level information is a bit difficult to use for decision making, for example, by consumers or companies, because we don't buy diets, or we don't produce diets. We buy individual products, or we produce individual products. So to evaluate individual products, we have developed this nutrient index-based sustainable food profiling model, which combines two quite new methodological approaches of life cycle assessment. So we have a nutritional life cycle assessment part and then planetary boundary-based life cycle assessment, which are integrated in this model. Okay, so the basic components of the model, there's these three parts. We have the environmental impacts of the product in all the impact categories that correspond to planetary boundaries. Then we consider the nutrient content of the product in relation to the recommended daily intakes of each nutrient. And then we have the planetary boundaries, which are basically integrated as share of planetary boundaries assigned for the product. So we have to kind of downscale the boundaries for the whole world to individual products to be able to use them in this kind of assessment. And if we take a closer look, we have the about how the model works. So here we have the nutritional LCA part. I'm going to explain this by showing figures, but in the paper it's also given as formulas. So if you like formulas more, you can find all of them in the paper. But basically, the nutritional LCA part includes assessing the nutrient content of the product in relation to the recommended daily intakes. And to use this information in this model, we have to compact it into one value. So we use different nutrient indices, which presents basically the average of nutrient intake in relation to the recommended intake. And there's many different nutrient indices that exist that has been developed for LCA use, and they all have a bit different nutrient selection in them considered. And then we have the second part, which is the environmental impacts. And first we have to have the environmental impacts assessed in the impact categories that corresponds to planetary boundaries, and then they are divided by the nutrient index score. So basically we end up with the environmental impact per unit of nutrient index score. Then on the other side, we have the planetary boundary-based LCA, which basically means that we have to downscale the planetary boundaries defined for all human action to match with the unit we use in the nutritional LCA part. So therefore, we first have the planetary boundaries, which are also called safe operating space, and the commonly used abbreviation is SOS. That's the one we also use here. And then we first downscale it for the whole food consumption per person per day, because also the nutritional part is for daily recommended intake. And this part is done by using the boundaries defined for the food system, the whole food system, by the Eat-Lancet Commission. And then we divide it by global population and number of days in a year. So globally, basically everyone gets the same share of the boundaries for their personal food consumption. Then we need to further downscale to make the planetary boundaries match with the unit of nutrient index score. And that's basically why the share of the safe operating space is further divided by the number of all beneficial nutrients that have daily recommended intake, and then multiplied by the number of nutrients that are considered in the index. So it can be used with different kind of nutrient indexes. And then in the last step, these two are combined by dividing the environmental impact per unit of nutritional index score by the planetary boundary per unit of nutritional index score. So this basically means that all the values that are over 1 are above the planetary boundary, and values that are lower than 1 are considered sustainable in this model. But next I have some examples how we have applied the model and some results. So we tested the model using a total of over 500 foods from 3 different product groups that represents different meal components. So we have the protein-rich foods, then we have sources of carbohydrates, and then vegetables, which also include some fruits and berries. And these products and the nutrient composition was derived from the Finnish food composition database. It's called Plenary. And the environmental impacts were derived from the Agribalis database in the environmental impact categories corresponding to planetary boundaries. So we have climate change, nitrogen cycling, phosphorus cycling, freshwater use, land use, and biodiversity loss. We also did some sensitivity analysis with specific Finnish environmental impact data, but it didn't affect the results much. And as the nutritional indexes, we used the Finnish product group specific ones that we have developed before, and they were calculated for all population groups, and then we used the weighted average in the model. Then here we have some examples of the results, because there were so many foods assessed. All the results for each food can be found from the supplementary material of the paper, but here we have now the 15 best and the 15 worst performing products in the product group of sources of carbohydrates. And you can see that the values over 1 indicates that the planetary boundary has been crossed, and they are marked with the red color, and then the sustainable ones are marked with the green color. And in these assessed products, foods like rye breads performed very well because they have very high nutrient content and very low environmental impacts. And in the worst performing products, you can see foods like biscuits and cakes, because they have very low nutrient content, but the environmental impact is not that much higher compared to breads. But then we have products like rice, which has quite high environmental impacts, and that's why it didn't perform that well. Also here we can see that some of the environmental impact categories are a bit more critical than others. For example, biodiversity is on the red zone for every product, which is also a bit of because of the challenges related to the biodiversity impact assessment. But overall, it's also very critical one in the e-cleansed work. And then we can see that some categories like water use is not as critical, because also in the worst performing products we have some foods that are in the within the sustainability thresholds. So this kind of assessment can also reveal if there are some trade-offs between different impact categories. And then we have some results in the from the product group of vegetables and fruits and berries. And as you can see here, the best performing products are different type of fresh vegetables like spinach and carrots, which have very low environmental impacts and very high nutrient contents. And they are a lot below the planetary boundary in many impact categories. And then in the worst performing products, we have some juices and canned products like olives and canned fruits, which has a lot lower nutritional values and also relatively higher environmental impacts compared to fresh products. Then we have some aggregated results, because it's a bit difficult to show all the over 500 products at once. So we aggregated the products into broader categories. These are the climate impacts of these 3 different meal components that we assessed. And so this line marks the minimum value and maximum value, and then the dot, the average of the foods within this product category. And we can see how the different categories perform compared to others. And as we can see here, the model ranks different categories quite similarly that what is our current understanding on healthy and sustainable diets, promoting and discouraging similar type of products. For example, we have berries and juices and vegetables that have sustainable options in the classes. Then we have different type of breads, flours, potatoes that are considered sustainable. And then we have some eggs and fish and different type of fish products, pulses products, offal dishes, because they have typically quite low environmental impacts. And then we have some crustaceans. And these are similar type of results from the impact category of land use. And you can see that the relative performance of the product classes are quite similar in each of the assessed impact category, but the relation to the planetary boundaries are a bit different. So some of the impact categories, like I said, are more critical than others. And this impact category, for example, land use, we can see that it performs quite similarly to climate impact. So little summary of the findings is that, first of all, we found that the model assigns the planetary boundaries to individual food products based on the nutrition they provide, which allows the foods that effectively fulfill their nutritional role to have a little bit higher environmental impact than less nutritious foods. And this enables the identification of absolute sustainability of food products and determines how far they exceed the limits. And this can really help informed decisions, for example, by consumers or by industry. And the product level results show that only few products are within the safe operating space, which shows that there's also unsustainable options in the product groups which are generally considered sustainable, which really highlights the need that we need supply chain specific information and that changes are needed both in the food production and consumption side to really achieve sustainability targets. And also, as I said, some of the impact categories are more critical than others, especially biodiversity impacts are critical, but also the assessment methods for biodiversity still need some adjusting, and that the product level assessments are stricter than diet level assessments because this product level assessment neglects the fact that the diet can be sustainable and stay within the planetary boundaries, because there can be some products that cross the boundaries and some products that are below the boundary. So there's this kind of it's possible that the products kind of compensate the impacts of others, and that's how the diet can still be sustainable. So the product level is a bit more strict. And in the end, the whole work, the aim of this study was to present the fundamental idea of this type of sustainable food profiling model. So there are still some limitations and uncertainties in the proposed procedure, and it needs some further future research. So first of all, we need to test how the profiling model operates with many different nutrient indices used as the functional unit. We would need really product chain specific LCA data to see how actual products work within the model and how well it differentiates between products from different supply chains. And then many of the environmental control variables, such as the phosphorus cycles or land system change, have very strong subglobal distribution. So as alternative to these global planetary boundaries, we should also use geographically resolved boundaries in this type of assessment works. And then another consideration is to how address nutrients to limit, such as saturated fat or salt, and maybe we should handle them as negative impact on human health or so on. And then also one thing to consider is how the share of planetary boundaries from the whole global boundaries are assigned to food system, and could that be somehow reallocated, because for example energy sector has maybe more potential to reduce their impacts than agricultural sector. But yeah, thank you very much for listening, and we have some time to discuss today, but you can also send me an email anytime. Thank
Okay, Venla, thank you very much for a really nice presentation. We first go to Chris, and then we have a short Q&A session, and then we split in groups. So thank you very much, and please, people in the room, leave your questions for after the next presentation. And then I'll invite Chris to give his presentation on the positive effect of data fusion. You're mute, Chris. Yes.
Thank you very much, Edward. And I have to say, I really enjoyed the presentation from Venla, and I have too many questions for her. But first of all, I will maybe concentrate on my own presentation. Let me just okay. So just to check, you can see my screen okay, Edward? Thank you. So rather a different topic that Venla was talking about, and this is really some kind of hardcore analytical chemistry. So I will try not to talk too much about some of the hardcore stuff and really talk about the general principles. So I mean, I guess everybody who's attending this webinar really understands food authenticity. What is it about? And it's about what we buy, what drives us to buy particular foods in terms of what's on the label. It actually might be things like Venla talked about the sustainability, about the nutritional content. It is about the ingredients to make sure that they are safe, that they're genuine, that they haven't been substituted. We make a lot of food decisions about where our food has been produced, how it has been produced, like the production methods. Is it organic, halal, kosher? But also about the variety, the species of what we're buying. Is it wild caught fish? Is it farmed fish? So we make many different decisions about the food that we buy, and we really hope and trust that what's written on the labels, who sells us our food, are actually telling the truth. Now, when it comes to data fusion, this is maybe an area that not so many people are familiar with in terms of what it really is. And quite in a simple way, it's about techniques that can take data from multiple sources and combine them. And by doing that, you can produce a more accurate result, or you can answer a different question or a combination of different questions. So it's very much about exploiting data that you generate. And this generation of data, there are many different ways that we can generate data, how we can combine it together, and how we confuse the data together. So I'm just going to take you through just a few examples of how data fusion might work. So here is one of my most favorite analytical instruments in the world. It's a high resolution mass spec, an LC-QTOF. Now, an instrument like this, it can operate in different polarities. It can operate in positive mode or negative mode, though some of the very modern instruments can actually operate in both modes. But can you think about, we will take our samples, extract our samples, analyze them in negative mode, then reanalyze them in positive mode, and then you can combine that data. That's one example of data fusion, just in terms of using exactly the same instrument, but using it in a different way. Another example of generating data, this time you use exactly the same instrument. You can use it in exactly the same mode, but this time you're using different ways to actually prepare your sample, different sample preparation techniques. And those different preparation techniques will be able to capture different analytical molecules. So again, by using a number of different extraction techniques, after that you can combine and fuse the data and really look at a much larger data set. So same instrument, different sample preparation. In terms of then different analytical platforms, here are some of my favorites. You can measure the elements that are present. Here's a very nice ICP-MS that can do that. You can measure the volatiles that are present in a sample, and here we have GCMS. And then there is the LC-QTOF, where you can analyze the extractables. So here's completely different analytes, all being measured in the same sample. And again, there is the opportunity to combine that data, to fuse that data together. And then, of course, we can use different instruments and different sample preparation techniques as well. So there is a multitude of different ways that we can generate data from exactly the same samples, by being clever with our sample preparation techniques and being clever by the types of instrumentation that we use in terms of generating the data. But it doesn't have to be very sophisticated analytical techniques. One of my favorite techniques is spectroscopy, molecular spectroscopy. It could be Raman, near infrared, FTIR. And this time you're actually generating data without any sample preparation. So here's another form of data, spectroscopy. I'm going to talk about ambient mass spectrometry as another technique in a few minutes. And that's another way where with very, very little sample preparation, you can actually generate huge amounts of data, of analytical data. Then we can go to a completely different level in terms of how we generate data. And that's by adopting what we refer to as the systems biology approach. We can generate massive amounts of data using metabolomics, proteomics, transcriptomics, epigenomics, and genomics. And then again, thinking about combining those massive data sets gives you the ability to really interrogate systems biology. And this is probably much more relevant in life science research and medical research than certainly in food-based research, particularly food authenticity. But the potential of this is absolutely enormous. Then I think my final example is it doesn't all have to be analytical data that you fuse together. And here is an example where actually you can take weather data, you can fuse it with data from mass spectrometry, LC-MS, which measures mycotoxins, and then you can look at the correlations between impacts of weather and the presence, or increases, decreases in the amounts of mycotoxins present. So I hope I've given you, quite a few examples of where data fusion can actually be done using different forms of instrumentation, different types of sample preparation, and using data from non-analytical data collection and fusing it with analytical data. Now, data fusion itself, there's actually what we call 3 levels of data fusion. We have low level, mid level, and high level. Now, just to kind of gently, just to gently walk through those different types of data fusion. Low level data fusion is really combining the raw data from 2 or more sources, and then you create a unified data set. Mid-level fusion is actually where you interrogate the features. So first of all, you extract the data, then you will extract the features from that data, and then you're fusing those features together. The third level is high-level data fusion. And this is really where you're taking the results of the different forms of analysis, the different forms of data analysis, and you're fusing those together. Now, some people in the field actually say high-level data fusion isn't data fusion, it's actually results fusion. But I will leave that argument to those people who actually work in this level of statistics. I'm just a simple analytical chemist, so I refer to low level, mid level, and high level data fusion. Now, why even think about data fusion? Isn't doing good analysis using a single form of instrumentation, collecting together huge amounts of data, is that not a tough enough job? So I'm going to take you through this particular case study. It's on one of my favorite foods, on salmon. And we embarked on a project to look at if data fusion will really help us decide on the authenticity of salmon. What we want to find out with what's on those labels of salmon. Is it genuine? Is it true? And the reason for that is for salmon, like many other food commodities, based on how it's produced, based on where it comes from, the price changes dramatically. So wild-caught salmon is more expensive than farm salmon. In some parts of the world, Norwegian salmon is more expensive than Icelandic salmon. It might be that Scottish salmon is viewed as being more healthy than coming from Canada. Now, when you've got such a big price differential, you've got massive opportunities for fraud, for people to cheat. Because if you look at those salmon steaks, they all look exactly the same. So how have they been produced? Where did the salmon come from? This was our research project to look to see what was the way that we could come up with the most reliable, the most accurate method in terms of finding out the provenance and production methods of salmon. Now, in this particular case study, we used two different forms of analytical measurements. Measuring the elemental content by ICP-MS, quite a standard tool in many analytical laboratories. The second technique was to measure the lipids, the lipidomic profile in the salmon samples using a technique called REAMS. And REAMS stands for Rapid Evaporation Ionization Mass Spectrometry. That's quite difficult to say, even though I've been working with it for 10 years. So REAMS you might not be so familiar with. So what is REAMS? So here's a little video. REAMS itself is sold by Waters, and it uses what's called the eye knife. So here we have a little knife attached to a laser, and basically you put the laser onto your sample, you burn it, and the volatile materials get sucked up and then get injected. The vapor gets injected into your mass spectrometer, and here we see this happening now. The molecules are ionized, and then some of the contaminants are removed, and then those lovely volatile compounds get analyzed using the time of flight mass spectrometry. So that is REAMS. The beautiful thing about REAMS is there is virtually no sample preparation. You basically just have to burn your sample, and you can generate results of REAMS within several minutes. It is unbelievably fast form of mass spectrometry. Now, we have worked with REAMS technology for many years. We would claim to be kind of the pioneers, the leaders in REAMS work in terms of food authenticity. We've done a lot of work looking at, can we determine the species based on the burn profile of the lipids? Can we determine the breeds that are present? Can we identify what the production systems are? Was it done intensively, extensively, organically? We've done work on looking at the quality of the product. How fresh is the product? And we've also done work looking at the geographic origin. Where in the world was this type of food produced? So in terms of our work on salmon, this seemed to be a really good choice of analytical technique, because salmon contains a lot of lipids, particularly phospholipids. So in terms of what we did in our data fusion project, we took salmon samples, and we had salmon samples collected from many different parts of the world, different production techniques. Some were wild caught, some were farmed, and we looked at the fatty acid profiles of these, particularly things like DHA and EPA. And based on this, we could see really good separation using the data that we had generated in the REAMS, followed by chemometrics. So it was reasonably easy to tell the difference if it came from Alaska, Iceland, Norway, Scotland, using the REAMS technology. So we were very pleased with the REAMS results. In terms of the work on the ICP-MS measurement, again, what we did was we used a very standard sample preparation technique, applied it to the ICP-MS, and again, using chemometrics, we were able to look at this very nice separation between the salmon that came from different regions. So I guess what I'm telling you is the reams work really well. The ICP-MS work really well. Why do we want to apply data fusion? Now, in terms of the elemental composition, we did see lots and lots of different elemental profiles, and we are pretty sure we could track some of those that came from North America due to heavy amounts of mining. We could find quite a lot of cadmium in those samples that came from further north due to melting glaciers and so forth. So again, we were very, very pleased. But what we did in our project, and this is working from left to right, we undertook the reams analysis and the ICP-MS analysis on exactly the same data set. And we fused the results of reams and ICP-MS. We undertook quite a lot of different chemometric modeling on them, looking at lots and lots of different chemometric models. And when we had selected the most apt chemometric models, then we applied the mid-level data fusion from the reams results with the ICP-MS results. So that was kind of the workflow that we worked towards. Now, this is quite a busy slide. Now, I guess what I'm saying is the reams results look really, really good. When we did our validation, our internal and external validation, we found the reams to be 100% accurate. Very, very pleased. But what we did is we went further and we worked with some suppliers of salmon, and we asked them to supply us with some unknown samples. We analyzed them in the reams methodology. And of the 17 samples, actually the reams was only able to identify 14 of them correctly. It misidentified 3, despite all our efforts in terms of validation. With the ICP-MS, we went through exactly the same. It came up with an identification accuracy of 97% when we did our internal and external validation. But when we applied those same 17 samples from the salmon suppliers, we only got 11 of those 17 correct. And actually the ones that we got incorrect with ICP-MS were different from the samples that we got incorrect with reams. But, and here is the big but, when we combined the reams and the ICP-MS data together in the mid-level data fusion, we had 100% accuracy with those 17 samples that we obtained from the suppliers. 100%, 17 out of 17 correct. Now, what does this actually mean? So, we identified 18 very, very good, robust lipid markers, the biomarkers from the salmon. And we also identified 9 elements, which gave us a huge amount of information about the provenance of the salmon and the production techniques. And then whenever we combined those together with data fusion, we were able to achieve 100% accuracy. So for those people who are familiar with using this form of untargeted analysis using analytical platforms, it is rare, extremely rare to claim 100% accuracy. I've seen it in quite a lot of publications, and when I look at the publications, actually the validation hasn't been particularly good, but we went through a really rigorous set of validation to approach this. Now, we were so happy, so elated with our results. What did we do? We published this, and actually we published it in Nature Communications, and Nature Communications generally does not take research papers about food authenticity. But what they really liked about was the application of data fusion and how we went through a very rigorous exercise in terms of looking at many, many variables in the study. There has been a huge amount of interest in this publication. It was only published less than 2 years ago and has been accessed more than 9,000 times. So we're very, very pleased about the data fusion work. The young lady sitting beside the mass spectrometer, her name is Yuhua Hong, and this was her PhD. She has won a number of really prestigious awards, both in the UK and China, for her research work, and her study was absolutely fantastic. Now, we are applying this idea of looking at data fusion now in many, many different types of experimental protocols. This one happens to be looking at soya. Can we tell the geographic origin of soya? And when we look at the data, we think about the type of analytical test we applied, what type of analysis did we do on it, and how accurate was the results. Now, when we look at the individual methodologies, when we look at just using NIR, actually the accuracy isn't so good, 80 to 85%, and that really isn't appropriate. But then whenever we start to apply a second methodology, ICP-MS, and then start to apply different forms of data fusion, the accuracy increases and increases, and we've got it up as far as 96% at the moment, and we're still working on it. But the reason I included this is, my goodness, do not think that fusing two different types of analytical tests with a single form of data fusion will give you the best result. You have to look at many, many different variables. So the final slide is, what are we doing with all of this? Nice publications, but in our food authenticity company, BIA Analytical, we have developed a beautiful handheld tool where you can go out and you can do authenticity analysis. And the accuracy of those results are between 80 and 85%. You can send samples to our laboratory, which can be analysed in an ISO 17025 method, and the accuracy of those results can be 95, 96%. But what we're really interested now is, let's start thinking about applying data fusion to the handheld plus the laboratory results. Can we achieve 100%? That's the goal of our research at the moment. So I'm going to stop talking now and stop sharing and pass you back to Edward.
Okay, Chris, thank you very much for a really nice presentation with very good results. So the papers are now open for questions. So if anyone has a question for Venla or Chris, please speak up. And I understood when Chris started that he had some questions for Venla. So I'm looking forward to the discussion.
So would you like me to start with one question?
Yeah, if you have a question for Venla,
okay,
that would be fine. Yes, yeah.
So first of all, Venla, I really enjoyed your presentation. What you're working on is something that's incredibly important. I have done some work in it myself. And well, I've too many questions for you, but I guess I'll start off with, I saw that you mentioned Eat Lancet quite a lot of times. You've based a lot of your modeling on Eat Lancet. But did you know that there are now 76 publications? One of them came from myself and some colleagues that have critiqued, that have criticized Eat Lancet. And for many reasons. There are serious doubts about some of their methodology. There are serious doubts about the nutritional adequacy of Eat Lancet, about the affordability of Eat Lancet, about the regional relevance of Eat Lancet. Why did you choose to work with Eat? Why did you choose to model around something that has been really quite contentious?
Yeah, thank you. That's really good question. And well, the Eat Lancet work is very well known. It's very something that has been used a lot. But actually, I noticed some the documentation of the work is not so detailed that when you start looking around that, how did they end up, for example, with this biodiversity conclusions that they did, it's not very clear. in all parts, but actually what we adapted there is the idea that we have to have like the environmental thresholds, but then also some minimum requirement for the nutritional quality of the products, because otherwise, if we look at the environmental impacts, it just shows that we shouldn't consume anything because everything has a negative environmental impact. So we also need to have some criteria for the nutritional part, but then as the nutritional needs, we used the Finnish nutrition recommendations. So we didn't take the nutritional needs of people from the Eat Lancet work. We used the recommendations we have in Finland, and I think if the model is adapted elsewhere, they should also use the local recommendations for nutrient intake. But yeah, so basically in the end, what we adapted from there directly is the share of the food system from the planetary boundaries. And based on our work and reading through all the documentation, I would suggest maybe reconsidering how the boundaries for the food system are defined. But also I know there's going to be update to the Eat Lancet work published this year. So maybe this is something that they address in the new version. And then we can also update our model and so on based on the updates that Eat Lancet does. But I think the basic idea that they have is very good, to have sustainable food systems where everyone gets enough nutrition and it works within the planetary boundaries. So that's why we used that one.
Thank you.
Edward, you're muted.
There's someone in the audience that is waving. We have Schober Schmutz. Please
Yeah, he can use
speak up.
He can use the microphone. It's allowed.
Please, can you unmute and then speak?
No.
Yes.
Yes. I'm sorry, I don't have the camera on. I don't know why. So, but I would like to know whether you also did your calculations for a recipe, not only for single food components, but for recipes.
Yeah. At this stage, we only looked at single foods, but we are now planning to apply the same model for meals and how it can be used for designing sustainable and nutritious meals. But it's very in the beginning. So hopefully we get some results.
And one more question is, if you have the value, the nutritional value, you already said it could be possible that you have to adapt it to different nutritional needs in different countries. But isn't there one calculation basis for all of them that is just to be adapted, or are there totally different calculations?
No, I think just the recommended intakes could be adapted to the region in question. Probably it doesn't make that much difference, but for example, in Finland, we have quite high recommendation for vitamin D because we don't get that much sunlight here. So it could be a bit different in other.
But, do you know the Nutri-Code in Europe, in Germany, for example? I'm coming from Germany.
No.
So that's what I mean. There are so many Nutri-Codes or nutritional calculations. Is there some study that you could tell me where I can find an overview on all of them?
Sorry, I'm not sure exactly what are you referring to.
So the one you took is the nationally recommended one for your country, for
Yep.
And there are no different ones that you had to choose from, or because you can calculate the nutritional intake differently in Germany, but I did not.
Okay. So maybe I'm not aware of that
Okay,
or
thank you.
how it works. So
yeah, I don't want to bring you in some other time.
Okay,
Thank you.
but what was this that you mentioned? I want to look it up now that you mentioned it.
The NutriCode in Germany is a label on the food that
Okay.
makes it from green to red, whether you should, which you will have a good or bad nutritional level.
Okay, so it's similar to the Nutri-Score, for example.
Yes.
Okay. Yeah. Yeah, we don't have anything like this in Finland at the moment.
Okay.
But sure, yeah, there's a lot of options in those ones too. But basically, even though we have integrated the nutrition into the model, the end result that we get is always environmental impact. So maybe if we use it for labeling or something like that, then the label is always about environmental impact in the end. But it's different from nutritional labels.
Do we get your email address in the end with the protocol? So if I have another question, I can call.
Yeah, sure.
Thank you.
Thanks.
I think it was a very interesting question because it follows up on your research. I think you did the basic research. We know a Nutri-Score is around, and in the Nordics you have the keyhole. I don't know if you have the keyhole in Finland, but I know it's around in Sweden. And the keyhole is only put on products that are considered healthy. So it only shows the logo on the, let's say, the healthy products. Another aspect is that you could try with such a front of pack label to show if products are healthy, but you can also show if they are sustainable. And I think that's what you are more looking into with your research. And what I see is that with the European Commission, there's a strong desire to have an eco label on products, but that is on all kinds of products. So it can be textile, it can be shoes, it can be cars, whatever. But when there's such a general initiative, it could also count for food. So it would be an interesting development if the European Commission really wants to go for an eco label also for food, and then your work can be really relevant. And then ideally, and that is why it's so nice that we have Joe Livingston in the audience, is that we could do with one label. And I think that's also what I understood from, let's say, from your work, from your abstract, is that it's then there's not so much room to maneuver when you want to design a healthy and sustainable diet. There's not so much discussion or variation. So maybe Venla, you can comment on it, and Joe, maybe you can comment on it.
Yeah, thanks. I think those are really good points and really good things to highlight. I think especially if we do like eco labels, at first maybe we have to use some more general environmental impact data, because the lack of data is really something that is often a problem with the environmental impacts. And if we get supply chain specific data that we know that this specific product is produced on like the specific farms with these methods and so on, so then we can see the variation between the products, and we can really maybe even see that this bread is sustainable and this bread is not. But currently we're not able to do that because there's a lack of data, but it would be very interesting to see how diets can also be sustainable, like even though they would include variety of different foods. I think if we had a lot of data, we could do different kind of diet optimization and see how different the diets could look like. But it's something that maybe we can do in the future and see how it works.
Yeah, we're sort of having the same sort of issues, the data, like a lot of those databases, you can sort of pick and choose almost what you want. There can be quite big differences as well. Like we use Place a lot, and then there's a few other ones. And like you could have two different, say, rice, they could both be called the same thing from like the same country, and they could have totally different environmental impacts. So it's kind of like you can pick what you want, really. So it doesn't really help with the trust of scores at the minute, but I don't know who. I suppose the question is who's going to get that data. And why would they bother at the minute when there's nothing really, what sort of incentive would there be to get that data other than like altruistic sort of environmental protection?
Okay, thank you. I propose that we now split in groups, if that's okay for you. Then I made 3 questions for each group. There will be a group with Chris and there will be a group with Venla. And then we can come back 5 minutes before the end and then report to each other what we have been discussing. So Manuela, if you can bring us to the groups now. Okay, welcome back, all of you. I hope you had a nice discussion in your group. I will first try to report very quickly of my group. We talked about 2 questions. I think we had a nice engaged discussion. First, the first question was where to start with the environmental impact assessment, or we're defining which is a healthy diet. Joe said that it's well, people in panels mostly are more concerned about their health. Bridget mentioned that she has insight in what people are eating, and she tried in tests to add the CO2 level to food, but it didn't change their recipes, especially not in traditional recipes. But it could be a nice idea to give people a CO2 budget, like they have now a financial budget. And in fact, this was tested by Carbon Cloud, and I will share the link with Bridget from this research that I've seen. And then Venla said that well, to do all this work really thoroughly, we need to integrate different data and work with different experts so that we get a really good end result. And also Bridget mentioned there's a lot of food illiteracy. A lot of people have no idea about the health of their food, so they need to be educated. The second question what is needed to get decision makers to act based on scientific data like this. And decision makers can be consumers that decide what they buy or what they eat, but also policymakers. Bridget mentioned that policymakers can decide to put a label on the packaging. It can be an eco label, it can be a Nutri-Score-like label. Bridget mentioned that it's very important to reach, let's say, larger kitchens, university kitchens or restaurants or canteens, and to train those chefs, because only the chefs that work in large institutions or large chains, now they can work with sustainability, but chefs working in smaller settings have quite some difficulties. I mentioned myself that we could have a tax on red meat or no tax on fruits and vegetables. And then I came to the observation that in the work of Venla, that berries, that they sometimes seem to have quite a high impact. And Venla explained that this is because the berries were from farms and sometimes they were transported. And then Steina at the end asked the question if we should be working per 100 grams always, or maybe sometimes per 100 calories. And Venla just finished answering this question. That is from my side. I don't know, Chris, if you can report a little bit on your conversation. Let me see.
Sorry, Christopher. Try now, please.
Yeah. Yes, now you should be able to speak.
Yes, sorry, my camera has stopped working. I don't know why, but I can just kind of talk through our group. So the discussions were extremely good, and I think what was raised were some of the barriers to actually using data fusion, and that is the cost, the expense. Food authenticity can be very expensive to start with, and thinking of having to use 2 different expensive types of instrumentation, very nice for researchers, might be applied by some regulators, but certainly not appropriate by the food industry. And I think the real opportunity lies in fusing data from very low cost platforms, like I described, the little handheld scanners. I think we also talked about some of the opportunities in terms of applications, and there was a lot of those. We talked about using it to olive oil was discussed, and there are already a lot of different methods for olive oil. And wouldn't it be amazing if you started to think about fusing some of the data from the same samples, but applying by different methodologies? We think that would be very exciting. And not only measuring things around food authenticity, but food quality and food spoilage, for instance. And it can be very, very difficult to do food spoilage measurements. And we thought about, my goodness, we could use, again, these very simple tests, fuse the data from those tests together to give indirect measurements of how the quality and the age of different foodstuffs. So that was really our discussions, but lots and lots of ideas about lots of applications. So it was very positive, Edward.
Okay, thank you very much. We have reached 4 o'clock, the end of our webinar. We thank you all very much. Very soon, the webinar will be uploaded on the Titan website, and then you can all look back, and for sure we will post about this. Thank you all very much for presenting and for contributing, and have a nice afternoon. Bye-bye.